I welcome you all for the data structure class. So today we'll see with the next one more data structure, that is queue. Okay, already we've seen with the concept of stack. Okay, so in the queue what happened in here, we insert the elements from the one end and we delete the elements from the other end. See here we are having a two ends, rear end and front end. Okay, so we are having a two ends. Okay, so so from the rear end we always perform the insertion operations. So from the rear end, what we do the insertion process, and from the front end we do the deletion process. So here suppose if I insert my first element from the rear end, and the deletion will be always takes from the first element only. Okay, so here what happens, so here totally how many locations are there? 6 locations. So suppose I've entered the 6 elements like 1 2 3 4 5 6. So what happens, initially 1 will be inserted, next 2 will be inserted, like this way. My 1 will be goes where? Here in the last. Next at last insertion value is what? 6. So the first deletion element is what? 1. Okay, so deletion will always takes place from front. Okay, insertion will be always takes place from the rear end and deletion will always takes place from the front end. Okay, hence this data structure is known as what? FIFO. That is nothing but first in first out or last in last out. Okay, first in first out or last in last out. Whereas in stack what happens, if we insert the first element, that element should be deleted last because it is first in last out. But whereas queue, first in first out, because the element which is inserted first from one end, that is deleted first only from the another end. Okay, here insertion takes place at one end and deletion takes place at the other end. Hence, so element which you are going to insert it, that only will exit first or delete first. Whereas in stack that is not possible because you are having only one entry, hence deletion will also takes place from the same entry, hence which is the last element you are inserted, that is deleted first in the stack. Whereas in queue, the element which is inserted first, only that element is deleted, hence it is known as what? FIFO, first in first out or last in last out. Clear? So next, here again we can perform the queue operations implementation by using array or linked list. So if you take the array, what happens, I'll be declaring the two variables, front and rear. Okay, so initially these values will be always -1. So where even in the stack what happens, you kept the top value as -1. It indicates that the stack is empty. Same way the queue empty condition is what? If both the values are -1, it indicates that queue is empty. Next, which are the different operations we can perform on the queue? That is creation, insertion, deletion, overflow, underflow and display. Okay, so first I'll tell you creation operations. So how you create the operations in the queue? So in the creation what happens, first you declare the size of the queue. For example, int queue 5, it indicates that the queue is having a memory size of 5. Okay, then I declared int front equal to -1, int rear equal to -1. It indicates that initially my queue will be having a 5 locations and each front and rear value is -1. Okay, so this is about the creation of a queue. Okay, next one is what? Insertion. So before I go for the insertion, first I will be checking that whether the queue is empty or not. If it is queue is not empty, it shows that queue is full. Okay, overflow condition I will be checking that. So how I need to check for the overflow condition? If the rear value is maximum size, because for example if I set my suppose if I take my queue size as 5, so what is the maximum rear size should have? If I start from 0, it should maximum size is 4. If rear value is 4, it indicates that the queue is full. If rear value is 4, if rear value is n-1, it indicates that if the front value is 0, rear value is 4, or if the front value is 0, if rear value is n-1, both are same. So it indicates that the queue is full. So then I will be what I need to do? It is for overflow. Hence I need to increase the size of the queue. So how I can increase? So I will be increasing that front equal to front equal to rear plus 1. So here what happens, where I need to insert my element, the new location, rear value is 4, so fourth location is already filled, so fifth location I need to go. So how I do, rear value is 4 plus 1 5, so at that time the front value will be inserted into the fifth location. This is how I can insert. Okay, so this is for what, checking for the overflow condition. If it is overflow, we can increase the queue size. Otherwise, if the queue is normal, if the queue is empty, what happens initially, my front value is -1 and rear value is -1. Initially you are checking, when you are inserting, front is equal to -1 and rear equal to -1. Okay, at that time what happens, when I insert the elements, my front value becomes 1, front value becomes 0 and rear value becomes also 0. Then I go on inserting. So every time if I insert, what happens, my rear value will be go on increasing. How equal to, rear equal to rear plus 1. So rear value goes on increasing one after the other. Like this way I will be storing the elements in the queue, that is insertion. Next, for the deletion, if I want to delete any element, first I will be checking for what, underflow condition. That is, if my rear value is -1, it indicates that there is no empty elements in the, so queue is underflow. Hence I will be checking, okay, no elements for deletion. If not, what happens, every time I delete the element, so I will be checking front value and rear value. Then I will be go on decreasing the rear value. So it indicates that rear equal to rear minus. So rear value one by one elements go on, for front value goes on decreasing. Okay. This for the deletion. Overflow checking, what happens, if front equal to -1, rear equal to -1, it indicates overflow. Sorry, if front equal to 0, rear equal to n-1, it is overflow. If front equal to -1, rear equal to -1, it indicates the underflow. Then display application, how it will be happening. Otherwise, how I will be going, front equal to 0 and rear equal to n. So I will be go on increasing the front value until the rear value encountered. So I will be go on displaying elements from the first end to the last end. Okay. So this is how I will be performing the operations. Clear? So initially what happens, both the values are -1, front and rear. If I want to insert, every time the insertion, the rear value goes on increasing. Okay, and I'll be checking for the condition for overflow and underflow. For deletion also, every time I insert the new element, delete the element, my front value goes on increasing. How much? The front value, when front value is equal to rear, it indicates that the queue will become completed deletion. Then I'll be decrementing the values both to -1. It indicates that the queue has been totally empty. So every time I delete the element, my front value will be go on changing. Initially the front value is what, -1. It's 0 when you are having elements. If I delete the elements, next front equal to rear. Like this way I go on deleting elements. So this is the part of the queue. So queue, again you are having a different type, circular queue and other double-ended queue and all. So that we'll be seeing in the next class. So tomorrow I'll be uploading one more video, so you can go through that video. So up to that you are having for your IS syllabus. So regarding that I'll be uploading the notes, and at 12:15 we'll have an interaction class. Okay, sorry, at 11:15 I'll be sharing the interaction class. Thank you.